Hello and welcome to today's Leetcode challenge. Let's begin our question, falling a little bit behind. So question 382, linked list random node. So given a stringly linked list, return the random node's value from the linked list. Each node must have the same probability of being chosen. Implement the solutions class solution that gets as a parameter a head of type list node, initializes the object with a head of the stringly linked list head. Get random chooses a node randomly from the list and returns its value. All the nodes in the list should be equally likely to be chosen. So, what was it? What was the terminology that they used? A singly linked. I said stringly. A singly linked list. Singly linked list is basically like a caterpillar. You start with the head being one, and each node, the head being a node itself, points to the next consecutive bump in the caterpillar. So the head points to the head minus one node, the next node, and so on until the tail points to null, to none. Basically, the list node next is equal to none. So what I'm thinking of doing is we have a couple of options. We can simply in the init, we could discard the linked list completely. And once we discard it, if we put it all into an array, then simply doing get random with a math.random function of from 0 to the length of the array would give us an index uniformly picking up one of those values. That's one solution. The other solution is to preserve the linked list as a linked list and start at 0 and randomly go up to a number, some number, a random number that is less than the length of the linked list, and return the value of the node that we end up on. Yeah, I don't know why this is a medium. let's use the first approach. The first approach would be what I think is kind of more memory intensive. The more memory intensive approach would be to to uh, the more memory intensive approach is to leave the head as is, so no conversions to a array, to a list of those values, and simply calculate something called the size. The size is initially 0, but let's get a variable, node, is equal to head, and while node does not equal head, we say that size is plus equals 1, and node equals to node.next. So we're iterating over all of our nodes until we reach the last one, and each time increasing size by 1, such that at the end of the day, when the constructor is completed, size represents the length of the array, and head, which we actually should also memorize, head, and head still points to the beginning of the array. Now what we will do here is while we'll say that what would we call this? Index is equal to self.size, and while index greater than 0, we will say return while let's say self dot no what would I call this? Node is equal to self dot head, and while I say node equals to node dot next, and finally just return the node.val. The only issue here is that index cannot be constantly the size, right? Index has to be, and I'm sure that the math people here, or actually anyone that develops there's a random function that is used often in Python, something like this. Let's say that there's 10 elements in the array. Size of 10 times random, which gives a value from 0 to 1, not inclusive. We will also, I guess, math floor this so that we're not hitting a self that size, sorry. And index floor, I spelled floor wrong. And module is not callable. Let me import random and then random.random, I believe. This should, because no type, next. Wow, okay, so here I forgot to reduce index by 1. But anyway, this is definitely one of the faster solutions that gives a 73 runtime. But yeah, very simple. We leave the linked list as is, just memorizing what head points to. And while the node, and in this constructor, we also get the size of the linked list, of it being size with this while function. And then with this while loop. And then in the get random, we use both of those two values. We use the actual linked list and we use the size, both of which give us the ability to first figure out how randomly, how deep dive into the linked list we should dive, randomly from 0 to 1 minus the length of the linked list. And as we are iterating over the linked list, the one that we end up on, we return the value of. Let's see another quick solution. I'm sure that this one, well, I'm not sure, but it could be faster. Let's say linked R. We don't care about the size anymore because that's going to be in the array, but we say self append and node val. And here, we no longer care about the linked list. We actually completely discarded, and the garbage collector is going to pick that up. But what we're going to do here is do random.uniform, I believe, from 0 to length of self r, and simply return the self r. This should also work. While node. Okay, while head. While head is going to be equal to head.next. Self r append head and return random uniform. List indices must be integers, not floats. So uniform actually, I guess, returns mm, a float. Can we do this? Can we convert it into a list? Yes, we can. And yeah, a little bit faster. Simply what we're doing here is creating a array out of the values that exist in the linked list. And that's it. And then randomly choosing one of those values uh, from the array. The uniform function in statistics is known as a, a probability density that is equivalent from the start to the end, which is what this returns. And the int is to convert it from float to int. So I would say that these are the two probably most credible solutions. Let's see if there's something that's more. Let's see, so lambdas, these are using some weird files. These are doing the same thing except they're keeping track of the length, which apparently is giving a lot of a faster response. Maybe math.floor random. Let's try this approach just to see if we can improve our speed a little bit. Self.size equals 0. And we don't care about this. We say self.size plus equals 1. And then here we're going to return let's see, math floor of self.size. No. Self.size times random. Yeah. Yeah, and same speed. So yeah, I wouldn't worry about this too much. This is a pretty easy solution, and the people that are getting faster responses are utilizing the file system, which is, I feel like, is cheating. So anyway, feel free to use this. Thank you for watching. See you later. Bye.